Hi everyone. In this video we're going to talk about the topic of lighting systems in kitchen and bath design. Remember, this is our residential construction and systems course, so we are focused on the technical side of lighting rather than the aesthetic side. In this video I'm going to cover lighting basics, day lighting, and artificial lighting sources. In the next video, I'll cover the California Energy Standards and lighting controls requirements. And then we'll finish up with some recommendations for lighting design for kitchen and bath. Here we go. Before you get started watching these videos, I'd like you to go ahead and read Chapter 20 of your textbook on lighting. And also this resource that you see on your screen here, Residential Lighting Guide from the California Lighting Technology Center of UC Davis. This residential lighting guide covers a lot of the same material in your textbook, but then it goes a little bit deeper and covers California specific requirements. So that's why I'd like you to supplement with this. If you turn to the title page, the index, you'll see that I don't actually need you to read all 54 pages of this lighting guide. If you could, if you could read chapters 2, 3, 4, and then chapter 5 just through the indoor requirements and recommendations. You can skip the outdoor requirements and their examples. You can skip the initial introduction and the ending appendix, so it's a little bit less than you may be thinking, just for your information. Let's get started with some lighting basics. Here's a little bit of vocabulary words to teach you how to talk about different lighting concepts. First of all, the amount of visible light emitted by any light source is measured in lumens. Lumens is how we measure the amount of light. There's another measure. It's called efficacy. Go ahead and say that right now in the privacy of wherever you're watching this video. Efficacy, efficacy, efficacy. Efficacy is a measure of efficiency of your light source, and it's measured in lumens per watt. So how much light is emitted by a device compared to or in ratio with the energy that light source is using. So let's compare a couple of different types of lighting sources. Right here is a standard incandescent light, a halogen incandescent light, compact fluorescent, or LEDs. Right? And let's compare the lumens that they provide between 450 and 1600. So 450 would be on the dimmer side and 1600 would be quite bright. All right. And then down here we have a table of how much energy is used to provide that amount of visible light. Take a look at the standard incandescent. In order to produce 450 lumens, the standard incandescent would draw or would use 40 watts of electricity. It's a 40 watt. Okay. To move up to 1600, so a much brighter light, the standard incandescent would use 100 watts of electricity. Let's compare this down here to the LED. The LED, to produce the same amount, same number of lumens, instead of 40 watts of electricity, will produce 5 watts of electricity. Will use 5 watts of electricity. If we slide down to the brighter side of the scale, to produce 1600 lumens of visible light, an LED will use only 19 watts of energy. So if we compare these two types of light sources, standard incandescent versus LEDs, you can tell that the LEDs have a much higher efficacy, there's that word again, of lumens per watt. It produces more lumens using the same amount of energy. Or if you're trying to produce the same amount of lumens, it actually uses less energy, right? So those are a couple of terms that you need to know in order to intelligently talk about your different lighting sources. Moving on, you probably have heard this already, but in order to produce a good interior lighting design, you need to have some different layers of lighting. And these different layers have different functions. The first one is your general or ambient lighting. You can think of this as your overall lighting. For example, you're walking through a house, it's night, it's dark time, excuse me, it's dark, it's nighttime, and you hit the switch. Your general or ambient lighting is probably what you want to turn on at that time. The next layer of lighting is called task lighting. Task lighting is, as it says, for specific tasks. For example, you might want to have a lamp next to a couch in order to provide task lighting for the function of reading on that couch. That's one example. Also, you might have, for example, a desk lamp in order to light the task of doing work at that desk. For kitchen and bath, you might have special lighting at your vanity in order to light the task of grooming. You might have a individual light at your kitchen sink in order to light that task area. Your third layer here is accent lighting. Accent lighting is kind of adds the sparkle or the interest to the room. You could light your artwork. You could have specialty cove lighting. There are so many different ways you can use accent lighting to add to your general lighting design. All those layers added together will be your entire lighting design for the room. Let's talk about daylighting. Daylighting is literally lighting your room with the outdoor light of day that will come in through your windows and skylights. So in your screen here you see some very effective uses of daylighting in these beautiful artworks by Vermeer. And in these examples, the daylighting is being used as general or ambient light, but it is also very specifically being used as task lighting for these individual tasks. If you remember way back to the very first night of class, we did an exercise, a hands-on exercise, where you designed and built shading devices for windows. One of the reasons or one of the functions for those shading devices is to control the light that might come into your building and not get too much daylight, because that's a thing. Daylight can be very bright and you can get too much of it. So here we have on the screen a couple of suggestions in order to successfully daylight your room. And the first is, over here, for the most balanced daylighting, you should allow the daylight into the space from two directions, right? Having only one direction of light is less successful. So it could be two adjacent windows, could be two opposite windows, could be a window and a skylight. There's a number of different ways to do this, but two or more directions that the light is coming from just gives you a more balanced lighting system. Here's another suggestion right here, is to place your windows next to a sidewall. And in that case, you'll get some bounced light into your room. And the final picture here is just illustrating the fact that skylights and roof monitors are very successful ways to allow the daylight into your space. Okay. And a last caveat, We built those shading devices for a reason. Daylighting will allow heat to enter your building unless you successfully use those shading devices. The next topic I'd like to discuss is color temperature. On your screen here you see two different illustrations of color temperature, here from your textbook and here from the Residential Lighting Guide. Color temperature is individual to or specific to the individual light source. So over here on your textbook illustration, you can see some different types of light sources and their standard or middle of the range color temperature, because of course you can select ones that go up or down a little bit. So for example, a candle right here is a very, very warm light. And so we see that way in the warm side of our color temperature. An incandescent light, which if you're like me, you're very familiar with, you grew up with, is also an extremely warm color temperature. Here it is right in the warm side. Moving towards the cooler color temperatures are some compact fluorescent lights and your fluorescent tubes. Some very cool lamps exist. This is called a daylight fluorescent right here. And you'll see that natural light, some natural light, it can be very cool. A blue sky or an overcast sky can actually have a very cool color temperature. LEDs aren't on this this scale right now. Not sure why, your textbook didn't include them, but it used to be that LEDs were very cool and people didn't like them for that reason. But that has changed, the technology has evolved, and now you can get LEDs in the neutral and even in the warm ranges. Okay, so moving on to the other illustration here, we have kind of the same scale of warm to cool color temperatures. It's very warm. And we have a section in here labeled neutral. Now most of your designs you're going to want to specify lights in kind of the neutral range between 3000 and 4000 Kelvin. It's right here, 3000 to 4000. All right. When I was doing commercial interior design and specifying lights for office spaces, I always stayed in the neutral range. But this is a specific kitchen and bath class, so I need to mention that in your bathroom, and especially in your vanity area, you'll want to specify warm color temperature. Right? It's more flattering to most skin types, and most people much prefer a very warm color temperature in their bathroom. Moving on to color rendering index, also called CRI, that's the acronym. So CRI measures how accurately a light source renders the color of the object it illuminates. And it's on a scale of, well, 0 to 100. And 100 is defined as the color rendering index of sunlight. Why? Because we humans evolved on this planet and our eyes have evolved to work with the light of our sun. Right? So we think that that has the absolute best color rendering index, and so we'll compare other light sources against that standard. So in your residential lighting guide, it's got a couple of examples, this illustration right here. So here are two scenes, actually 3 scenes, each illuminated with a different light. On the left here is a light that has a color rendering index of 80 and a color temperature of 3000 Kelvin. Over here on the right, we have the scenes are illustrated, the scenes are illuminated with a light that has a color rendering index of 95, so it's a higher color rendering index, much closer to our gold standard of 100. Okay, and it has the same color temperature, so we're not changing the color temperature between these two sets of pictures. The temperature is the same, the color rendering index is different. So now compare the two pictures. All right, and you might want to pause the video here and pull up the residential lighting guide so that you can kind of zoom in and look closer at these pictures. But take a look at these pairs. On the left, on the right, all right, we can see the pairs, we can see the color, but look how much more vibrant the reds are in the picture on the right with the higher rendering index. Okay, on the left, the reds in those pairs are very washed out. All right, on the right, they're far more vibrant. Okay, and you'll see that with color rendering index, the first thing that you lose as you go down the scale is the reds. So why is this important? Why am I teaching you about color rendering index? Why is it included? Well, it's really important, especially in kitchens, as these examples show, that you be able to distinguish between your different colors, and also to be able to enjoy those different colors. It's very important in bathrooms for people to be able to distinguish the colors, especially in their grooming activities. With the makeup and the clothes, what your ideal is that someone will get ready in your bathroom and then they'll walk outside and they will look the same. All right, you want them to be able to get ready using the same or similar color rendering index as if they were outside. Okay. For our next topic, I want to give you just a couple more vocabulary words. All right, this course is big on learning new vocabulary. And the first one is the word lamp. But Sarah, I know what lamp means. Well, it turns out that in lighting design, the word lamp has a very specific meaning, and it does not mean this lovely table lamp right here. The word lamp is actually defined as the interchangeable bulb or tube that constitutes the lighting source in a lighting fixture. So when a lighting designer says the word lamp, they are meaning the bulb, this one right here, or the tube if it's a fluorescent fixture. Okay. The second vocabulary term I'd like you to learn is lighting fixture or luminaire. Okay, these are the same thing, two words for the same thing. A luminaire is any light producing device that's permanently or hardwired to your home's wiring system. Right? So here we have an example of a track light. That is a luminaire. Or the assembly, and it includes the mounting base, the socket, and any features that reflect or disperse the light from a lamp and that are fitted into the fixture. Okay. So that's the definition of a lighting fixture or luminaire. All right, so we're being very, very specific about these terms. Let's talk about some different types of artificial lighting sources. They're all artificial, remember, because we've moved on from talking about daylight, which would be your natural lighting source. So here in your textbook, table 20.1, we're comparing different types of lighting sources. So the first one that's listed is incandescent. You can have a light output of anywhere between 126 to 6100, it's very bright, lumens. The efficacy is low. It is between 8 and 20 lumens per watt. And the color temperature is very warm. We already mentioned that. Okay. The pros of this light source is that it has low initial cost. It produces good color and good color rendering index. It's convenient, it's dimmable, there are many lamp shapes and sizes. The cons of this light source is that it is the least efficient of all the different types. And there's a huge con in that it's no longer allowed in California. All right, so you cannot specify incandescent lighting in your lighting design right now. The bulbs are fragile. There is high ultimate cost because of the short lifespan of the bulbs and the low efficacy. And also these incandescent bulbs produce heat. Next, let's talk about fluorescent lighting sources. And I'm going to skip the straight tubes and move on to the compact fluorescent bulbs because that's mostly what you would select for kitchen and bath design. Your compact fluorescent has an output of 900 to 1100 lumens. It has a relatively high efficacy of 40 to 60 lumens per watt. And the color temperature is in the warm to neutral range. And you can actually select the specific fluorescent bulb you want for a particular color temperature. Okay, a range of them do exist. The compact fluorescent are efficient. The bulbs are long life. There is a choice of light color, that's what I just mentioned. There's also a choice of lamp sizes and shapes. So many different types exist. Unfortunately, they have a higher first cost, so the bulb itself is more expensive than incandescent. If you switch them on and off frequently, like we tend to do in home use, okay, that will decrease the lifespan of your bulb. And finally, a sustainability con to using fluorescent is that the bulbs contain mercury. Moving on, I'm going to skip over halogen and xenon, so please read those on your own because they're a little bit less common. And move on to talking about LEDs. So LEDs is kind of our newest light source, and it is the most popular now. Why? Because it is the most efficient. So the output of your LEDs can be anywhere from 130 to 2800 lumens. The efficacy listed in your textbook here is between 25 and 30. Okay. However, since your textbook was printed, some great technological strides have occurred, and it has a much higher efficacy than that now. The color temperature of your LEDs can be to the warm to neutral range, which is what we want, and you can select that range when you specify your LEDs. You can select whether you want neutral color temperature or warmer. Okay, the warmer LEDs do now exist. LEDs are very efficient. They have a long lifespan. They are durable. Those are kind of hard to break. And your textbook mentions that the mini bulbs, they are very tiny, are very suited for under cabinet fixtures. You can put them basically wherever you like. The LEDs have a highest of these choices. They have the highest first cost. Okay, the bulbs themselves do cost more. They used to, and this has changed, absolutely changed, they used to have poor color rendering index, and so designers hated them, and people didn't like them in their homes because of this. That has absolutely changed. LEDs now come with the higher color rendering index. LEDs do produce heat, right here, okay, but far less than incandescent lighting, just so you know. they produce a little bit more heat than your fluorescent lighting. Okay, that's it for this video. We're gonna take a break here, come back with the next video, and we'll talk about some California specific energy codes and standards. Thanks everyone.